so let's talk about integrals using u-substitution. So, integrals. What do we mean by this? Let's go ahead and do a quick recap here. When we're talking about u-substitution, this is going to be for the harder kind of integrals, or a definite integral. If we remember, an indefinite integral is just taking a function and spitting out its antiderivative. And as opposed to a definite integral, which takes a function over some interval a to b and spits out a value of area for how much space is underneath that curve from a to b, area, right? So this is a definite integral. This is the kind of integral that we're talking about for the purposes of today's video. So let's get started here. So u-substitution. When I'm taking integrals, and it's a nasty function, I'm just kind of sick of it, I use u-substitution because u-substitution makes things so much easier. Let's break this down. Etymology is a really good way to get about going through things here. So here we have substitution. This means taking one thing and putting something else in its place. This u here, now this is short, okay? The u is short for u, okay? Now, what this means is I am really, really sick of taking these big, horrible integrals, so I'm going to use u-substitution, which means instead of me doing it, you get to do it, okay? This is really great. This makes my job a lot easier. So, I'm going to go ahead and put a function here. I want the definite integral over, let's say, 1 to 3 of x plus 1 dx. That looks like a 6x. Why should I care? I'm not going to have to do the problem. All right, so I want this definite integral right here, and I'm going to use u-substitution. So whereas normally I would stand here and do it, I'm going to let you. So, all right. How's it coming? Okay, good. All right. Okay, I'm just kidding. Here's what we actually mean by u-substitution. Let's have a function like this, and instead of x plus 1, we'll just write the letter u. So we can say that u equals x plus 1 for this function, right? So if u equals x plus 1, then we are really just talking about these points also being functions of u. So in this integral, when we have 1 and 3 here, these are points on our x-axis, 1 and 3, and the function's doing something over them, and we're measuring the area in between here, right? So since these are points, let's rewrite them as x equals 1 and x equals 3. Now this allows us to use u to make a function out of this. So we can say that u of x is equal to u, or x plus 1. So let's give ourselves a little bit more room here. We'll rewrite this. Here's our function. We have x equals 1, we have x equals 3, and we have x plus 1, which is just our u, not 6x, there we go, dx. And we know that u is x plus 1. So u of x is just going to be, x plus 1, sorry. So u of x is x plus 1. So what does that mean we can do? We can use this function right here to go ahead and change the points on the interval of our integral. So this is u of x, right? This is u of 1, and this is u of 3, okay? Well, what is this? This is our function x plus 1, so this is just 3 plus 1, which is 4. And this is just 1 plus 1, which is just 2. So we can rewrite our integral now as this over 2 to 4 u dx. But we can't write dx. This is u du now because we've replaced all the x's. So that's the purpose of this. And so we're not going to go through the steps of actually solving this. This is just more of a concept video and a joke at the beginning, as you can tell. This is what u-substitution allows you to do. It allows you to take a kind of unattractive or unruly part of your function that would be difficult to handle, replace it just with the letter u, and then use that to change the points of your interval to match that, so you can get rid of x entirely and just have the integral of u du over 2 to 4, which just means we're taking this integral with respect to u, just like when we differentiated with respect to x, or implicitly differentiated with respect to y or t or some other variable. So there you go. That is the bare essentials of what u-substitution does. We'll have some example videos up shortly.